So today we're going to talk about structural forms, and I have uploaded a file, a module unit 3A. We're going to make use of this structural form RMD file. Kindly open this, and we will be using OLK and maybe not today, the RGP files also. Okay, there are other files that I posted here. I'll show this to you later, these structural forms. Okay, so let's start our discussion by opening the R file that I shared with you. Okay, when we talk about structural forms, we look at the equation of our multiple linear regression and the form that it takes. So there are different forms that your multiple linear regression or simple linear regression might take. Okay, you have the log-log or the double log or log linear, or it's also called constant elasticity model. Okay, where all your regressors, all your dependent variables, your dependent variable and your independent variable are all in logarithmic forms. Okay, the second one is log-lin, okay, where your dependent variable is in logarithmic form, but your regressors can be a combination of log and linear. Okay, so it's called log-lin. When at least one of your independent variable is in log form, then we call it log-lin. When all of them are in logarithmic forms, then we call it log-log or double log. Okay, on the other hand, when the dependent variable is in linear form, okay, but one or more of your regressors is in log form, you call it lin log format. Okay, and then you can also have reciprocal models where your regressors are in their inverse form. I mean 1 over x, for example, like that. Then you have polynomial form where your independent variables are expressed in powers other than 1. Okay, and then we have the standardized variable regression model. Now these are the packages that we're going to use. Okay, quite a lot. Okay, but as we learned last time, we can load the Pacman package and then load these packages. Okay, so for me, I will not load them anymore. I'll give you time, guys, to load the packages. Okay, or you can, after you have, you can use this when you have installed the package. Okay, so once you're done installing the packages, guys, kindly chat in the chat box. If you're okay already. If you're done, you can start. You can already import this OLK dataset. Okay, you can import it. Let me just upload load the packages. Okay, if you're done, guys, kindly chat, please. Anyway, small group lang naman tayo, so it's easy to monitor. Okay, thank you, Matthew. Okay, good. Let's give your classmates a few more seconds to download the package. Some of you I know are having internet connectivity problems, so it's okay if you're not able to load the package. Anyway, we will be, this is recorded and we can just do this outside these class hours. Okay, so let's proceed, guys. I think that most of you have already loaded the packages. So we're going to first learn the log linear or log form. So when we say double log or log linear, it means that all your independent variables are in log form, okay, and also your dependent variable. Now, in our context, when we say log, what we mean is log to the base e. Okay, that's ln. Okay, that's not the regular log where the base is 10. So for our purposes, when in R, when you use log, the use is the log, the base is e, the exponential number. Okay, so let's let's move on. Okay, I hope you have imported the OLK dataset. This is output, labor, and capital. Okay, so we have here a record of the output, the labor, and the capital for, I think this is, I forgot the year this was taken, but these are real values. Okay, and we're going to regress. We're going to see the relationship between output. Would like to see the contribution of labor and capital to the output. Okay, so let me view this data. Oops, wait, I haven't run this. Okay, there. Okay, so you have 51 entries. This pertains to the 51 states in the US. Okay, 50, tapos ano ba yung isa, yung Washington DC. Okay, output, labor, and capital. If I'm not mistaken, these are in thousands. I'm sorry, I wasn't able to share with you the metadata. When you say metadata, it's information about the data. I wasn't able to give you, are these in millions or are these in thousands? And what do this output represent, labor represent, capital represent, and in what year? So it's important, guys, when you're working on the data to understand and to have information about the data itself. So it's called metadata. Okay, so we will just assume that, no, I'm not going to assume, I just forget the year when this was taken, but these are actual values. So the exercise for today requires that we look at the different structural forms, okay, of any equation, okay, of an econometric model. So when we take a look at the structure of OLK, it's a data frame with 51 observations of 3 variables: output, labor, and capital. So the type of variable is okay, it's integer. Okay, no problem about that. All right, but what we want to do is, you notice, guys, that the figures are quite high. Okay, these are in millions, these are in hundreds of millions. And it's best, I think this is in millions or in thousands. So it's best to manipulate the data in such a way that it's easier to handle the data. So it's good to scale the data. And one of the ways by which we can scale the data is get the log of the data. So here, we're going to convert the output. We're still going to call it, we're going to call it now log output. And we're getting the log of the output of the OLK object. Okay, also for the labor, we do the same thing. We get the log of the labor, log of the capital. Okay, so let's do this, this 3. Control Enter. Okay, and then we get the names of OLK now. Okay, ito na yung mga variables siya: output, labor, capital. And we now have the log output, the log labor, and the log capital. Okay, maybe we can check the first 6 observations. So there you are, guys. And you take take note guys, yung output natin, this is 38 million, okay? If this was in thousands, so 38 billion pa to, no? But notice, when you get the yung actual values niya, 38 million, ito 424,000, medyo malaking difference, no? Ito 2.6 million. However, when we get the log of the values, guys, tingnan nyo, nasa scale siya, di ba? Malalapit na sila, and it's easier to work in data in log, okay, compared to yung mga absolute values niya. Okay, for example, there are certain variables that normally kinukuha talaga yung log. Kunyari, population, GNP, GDP, no? Yung mga macroeconomic variables na ganun, since they are usually huge numbers, it's best to work with logarithm. No? Linolog talaga yan. No? Log of, so we have the log of the output, log of the labor, and the log of the capital. So we're going to use these variables and create a regression model. So since we're working with all log variables, kaya nga ang tawag sa kanya double log or log model. Okay? So that's the reason why we have now, yung first example natin is log model. Okay, so let's first understand the data. Let's plot the correlation matrix of the log variables. So we use the pairs function. Ang pairs, guys, let me check. Sa ano ba to? Core plot ba to? Pairs. Okay, nasa graphics. Okay, it's in the graphics package. Pero hindi natin know. Pero guys, it's always good to pag first time yung ginagamit yung ano, yung kaya yung function, what you can do is put the namesake. Ito yung namesake, yung package na pinanggalingan niya, no? Graphics. Okay, so let's run the first one. Okay, so here we have a correlation matrix ng log output. Okay, remember guys, by way of reminder, ang gagawin natin dito, i-regress natin si log output dun sa dalawang independent variables natin, si log labor at saka si log capital. So if we take a look at the relationship between correlation between log output and log labor, mataas, no? Very correlated sila. Tapos si log output at saka si log capital, also very high. Okay, the problem now is the correlation between log labor and log capital. Okay, mataas din siya. Remember guys, we learned before that we don't want the independent variables to be really correlated with each other. Kasi magkakaproblema tayo ng multicollinearity. Tingnan nyo guys, halos perfect yung correlation nila, no? Very, very high correlation. So we'll have a problem with this. I guarantee you, no? Masasabi ko na kagad. Kasi highly correlated si log labor at saka si log capital, which means that they will it will be as if they will compete for the position of trying to explain your dependent variable, which is your log output. Okay, so this is based on an economic theory. Yung output is a function of labor and capital. Okay, so let's use GG pairs, no? GG pairs, pwede rin. Okay, let's see. Okay, ano nangyari? Okay, here. Okay, siguro GG pairs ng OLK ang binigay niya. It's similar to the pairs function. Kaso ang GG pairs, guys, galing yan sa... Okay, sandali. Question, GG pairs. 45 yata to, if I'm not mistaken. Okay, sa GG ally pala. No? So this is from the GG Ally. Lagay ko lang ha. Hindi ko nalagay kasi. Okay, and where's our output natin? Asan na? Does not show, pero dito kita naman. Okay? So we can see here, guys, yung relationship ng, ganun din yung correlation plot. What's good about this is, okay, linalagay niya dito pati yung value. So let's try to see yung output and let's try to see this one alam muna, no? Log output, okay, and log labor. Log output and log, saan siya? Log output and log labor. I need to log output and log labor, log output, log labor. Okay, very high correlation, no? Very high correlation. Pero yung log output, log output and asan yung log labor natin? I'm sorry about that, guys. Log output. Okay, na-confuse ako dito sa diagram na to. Okay, so you have output, labor. Kasi ito yung log output natin, ano, guys? Log output and its correlation with, ito yung correlation niya with log labor. No? Ito. So it's very high, no? Log output and log cap. Okay, but log labor and log capital, ito, no? Very high din, no? Okay, and I don't see the correlation figure. Okay, so I think I should have hindi ko chinek yung ano yung OLK. Let me see. Let's see if we can okay, subset this. Okay, so lahat ng rows, and then wag isasama C just 4 to 6, 4, 5, 6. Okay, let's see if this will work. Okay, I don't want to get the correlation plot for 1, 2, 3, which are yung output natin, labor at capital. Gusto lang natin si log output, log labor, capital. So subset natin si OLK. Tingnan natin if this will work. Minsan sensitive yung ano. Ayan, okay. All right, so this is what I want, no? Okay, so if we can see, guys, here, okay, yung correlation ng log labor at saka ng log labor, okay. Log labor and log capital, 0.96. Wow, that's very high. We don't want that, guys. Gusto natin yung log output correlated with log labor, 0.97, correlated with log capital, 0.973. That's good. Pero yung log labor, guys, correlated with log cap, 0.96. Okay. We will be having problems with multicollinearity. We don't want the independent variables to be so related to each other. We don't want that. Ang gusto natin, yung mga independent variables natin are not related. Okay? Kung may relation man, konti lang, no? But not strongly related to the other independent variables. Okay. All right. So we begin with the equation, yung Cobb-Douglas production function. I'm not sure if you met this in your economics, but if you take a look, guys, at the equation, the output is equal to a certain function, a certain parameter B1 times labor raised to the B2 times capital raised to the B3. Okay, now what did we say about any regression equation? Yung regression equation natin, guys, yung relationship ng y at saka sa x. Okay? Ang x natin dito yung labor at saka capital. Pero dapat yung parameters hindi dapat linear siya. Okay? In other words, guys, yung parameters hindi pwede naka-square root, naka-squared, or naka-exponential, no? So dito naka-exponentiate yung yung B2 and B3. So technically, guys, we cannot use ordinary least squares here. We cannot use regression here. But there's a way. There's a way to go about this. Okay, when we manipulate this by getting the log. So kung kukunin natin, guys, yung mga log nila. So log of QI, ito yun, ano? And then you have three products here. Ito yung mga ano natin, ito yung mga factors natin. When you get the log of this, guys, the log of a product is equal to the sum of the individual logs. No? So log of B1 plus, tapos ito pwede natin ibaba to, magiging B2 times log of Li plus B3 times log of Ki. Okay? So what happened, guys? We were able to convert yung Cobb-Douglas production function, okay, which if you just take a look at it, hindi natin pwedeng gamitin yung ordinary least square sa regression kasi nga yung parameters natin naka-exponentiate. But when we got the log of the equation, naging ganito siya. Yan. So log of QI is equal to log of B1 plus B2 times log of labor plus B3 times log of case of I, of capital. Okay? So now we have an equation where yung mga yung mga predictors natin, yung labor at saka capital, they are now expressed in logarithm, and your dependent variable is also expressed in logarithm. So this now is what we call a log model. Okay? Now, yung log B1, since B1 is a constant, tapos pag kinuha natin yung log niya, constant pa rin siya. So we just represented it by A. Okay, so don't get confused about this. Okay, A siya. Okay, and A, guys, is equal to log of B1. So just take note of that. Okay, any questions so far? Any questions so far? Okay, good. All right, so pwede natin i-regress to, guys. No? Pwede na tayong gumawa ng model. So a model natin will be LM, okay, just a linear model where our dependent variable, our response variable is log output, and then tilde log labor plus log capital, comma, data is equal to OLK. All right? So i-involve lang natin dito yung mga log ng output, log ng labor, log ng capital. Hindi yung mga absolute values na. And because of that, guys, we have what we call sabi na nga natin, log model to or log linear. Okay? So there are different ways to call this model. Log, basta log lahat, guys, double log model yan. Okay, so let's run this. Sama natin yung summary din. Okay, ito yung result natin, no? First is we're recall yung function, yung formula. And then we have here yung coefficients ng model natin. Okay, intercept, log labor, and log capital. Okay, and they're all statistically significant, no? And okay, yung natin, yung adjusted R squared is 96.27. Okay? Ang taas, 96.27, which means that the regressors, the model, is able to explain 96% of the variability of your dependent variable log output. Ang taas, guys. And considering, ano ba yung data natin? Patanong nga, guys, is this a cross-sectional data or a time series data? Anong klaseng data to? Cross-sectional or time series? It's ano, guys? Fourth, ano siya? Cross-sectional o time series?
Hindi ako sure, sir.
Hindi sure? Hula lang, hula lang. Dali-wala naman
Time
paghula.
series.
Nanghula ka pa.
Ayun ang
Joke lang.
cross-sectional, sir.
Joke lang. Oh, cross-sectional siya, no? Remember guys, pag time series, you have an observation of one variable or several variables taken at different points in time. So kunyari, meron kang GDP, GNP, inflation rate, unemployment rate taken across 1970, 1971 hanggang 2021. Yun time series yun. Pero kapag ano lang guys, so yung time series guys, one unit, no? One unit being considered. Kunyari GDP, GNP, inflation rate, unemployment rate ng Philippines yan. So you're just taking a look at one unit, Philippines. Tapos kinukuha natin yung across several time, no? Across several time from 1970 hanggang 2021. Time series yun. Ito, okay? So ito naman guys, several units. So different states to ng US, no? And then snapshot to ng output labor capital, okay, of several states, 51 states at one point in time, 1970 yata if I'm not mistaken. So one time frame 1970, okay, several units, several individuals at different states. Okay, one snapshot in one point in time, cross-sectional yun. On the other hand, di ba sabi natin, yung time series naman, isang individual lang, isang unit lang. Okay? Philippines, kunyari, yung sinabi ko kanina, taken across different time frames, 1970 to 2021, then you have what we call a time series. Pag kinumbine natin, guys, si cross-sectional at saka si time series, what do you call that type of data, guys? Anong tawag na data na yun, guys? Letter P? Okay, may sumagot. Pwede, unmute na lang yung sarili niya. Okay, thank you, Aubrey. It's called a panel data. No? Sumagot pala si Aubrey kanina, cross-sectional. Thank you, Aubrey. So it's called the panel data. So kunyari ito, guys, 1970 to, no? Different states. Kunin natin yung 1971. Ganto din. 51 states. Okay? And then 1972 hanggang 2021. Okay, so yung 51 rows na to, multiplied by, kunyari 20 rows siya, 20 years, then that will be, ilan yun, 1020 observations. Yun ang panel data natin, guys. Kasi different units across different points in time. That's the panel data. So ito, guys, this is just a cross-sectional data. And for a cross-sectional data, tas napakataas ng ano niya, ng adjusted R-squared, medyo ano na, highly suspect na, no? Highly suspect. 96%. Okay? 96% yung adjusted R-squared. And then ito yung p-value natin, yung sa F-stat natin, overall goodness of fit, which is ang null hypothesis natin dito, A is equal to B1 is equal to B2 is equal to 0. So we reject that null hypothesis. We have strong reason to believe that at least one of these parameters is not equal to 0. Then we go to the individual test, no? Individual test of your predictors. So you have here log labor and log capital. Okay, ano ibig sabihin nitong 0.46 na to? Ano ibig sabihin nito? What we learned is that, di ba, sa dati na ang natutunan natin, for every 1 unit of log labor, there's a corresponding 0.468 units of log capital, increase in log capital. Diba? Yun ang natutunan natin, tapos ceteris paribus. So itong log cap, no? Ano ibig sabihin ito? For every 1 unit increase in log capital, there's a corresponding 0.52 units increase in log output. Okay? So however, guys, I said that because that's how we learned to interpret before in some multiple linear regression natin. Ngayon, kapag log na yung ano natin, yung model natin, iba na yung pag-interpret natin, no? Okay? It will be different. So kapag log, guys, the way you interpret this is, okay, how? Ang mangyayari dyan, guys, you get the number, itong 0.46 na to, or 0.47, and then attach percentage to that. Kaya nga, guys, ito ang tawag dito, elasticities. Ayan o, constant elasticity model. Ibig sabihin nun, when we interpret the output, we interpret it in terms of elasticities or percentage. So what does that mean? So how do we read this? For every 1% increase in labor, then there's a corresponding 0.46% increase in output. Okay, let me repeat that. For every 1% increase, percent ang tinitingnan natin, percent in labor. Notice I did not say for every 1% increase in log labor. Ang sabi ko, for every 1% increase in labor, isulat na nga natin dito, guys, para dapat ina-notes nyo yan, ano? So how do you interpret, guys, a double log? For every 1% increase in labor, there's a corresponding 1% increase. No, sorry, not 1, 0.42%. Is it 0.42? 0.46. Okay. Gawin kong 0.47 na lang, no? Round off na lang. 0.47% increase in output. Okay. And then you have your ceteris paribus. Okay, so that's how we interpret, guys. Okay, so interpretation of log labor variable. Okay? So paano naman si log capital? Ganun din. For every 1% increase in capital, there's a corresponding 0.52%, no? So percent din ang pagbasa natin dito. 0.52% increase in output, ceteris paribus. Okay, any questions, guys?
None, sir.
Okay. So that's how, guys, you interpret, no? Kapag double log. Ang double log, guys, lahat dapat lahat ng variables natin naka-log siya, no? Dependent variable at saka independent variable. Okay, so let's now continue. So that's how you interpret. Now, of course, the model does not stop there. Kailangan i-evaluate natin, no? So paano natin i-evaluate to? Dili ba ako may question? Okay, thank you. All right. So there's a package called Equationmatic. Okay. Medyo bagong package lang to, no? So kindly install this, please, and let's see if mag-work sa model natin. Kasi I was trying this yesterday, tapos medyo hindi pa nag-work eh. Pero tingnan nyo, guys, inyo, no? Kasi you can write the equation actually with this one. So install that packages and then load the library, load the package. Okay, so na-load ko na. Okay, and then we can make use of this equation, of this function. Extract natin yung equation kay model 1. Okay, si model 1 natin, di ba? Ito yung regression model natin. Model 1, di ba? Model 1. Okay, mukhang nag-skip ako. Pero sige, i-extract muna natin, subukan natin. Okay. So ito, guys, naka-latex siya, no? Naka-latex, no? So $, ibig sabihin yan, ito yung, when you use this, $, sa una, $, sa dulo, it means that yung ipapakita na equation should be outside, should be here. No? So dapat lalabas yung equation dito eh. No? Katulad nito, guys, tingnan nyo itong ginawa ko dito, no? Di ba? Ayan, no? $. Tapos linagay ko yung equation dito. Okay, so the equation appears here outside the outside this this inline, no? Di ba? Ito. Okay, now sayang kasi maganda to eh. Kasi lalabas, hindi na natin isusulat yung equation. So dapat ito, tingnan nyo, log output is equal to, this is A, alpha, plus beta sub 1 times log labor plus beta 2 times log cap plus the error term epsilon. Okay, so pero sige, i-ano na muna natin yan. But you can have this. Okay, in fact, you can use also the ayan no, pinasok na niya yung ano, di ba? Yung 3.89 plus. Okay, kaso nga lang dito medyo babaguhin natin kasi 3.89, okay, correct? Tama, no? So dapat pero may percentage to, no? And then, sorry. It's the equation anyway, so tama siya. Ito yung equation, but it does not print here. Dapat mag-print siya dito eh. Okay, so anyway, I'll try to decipher what the how do we make sure that we still generate the correct equation. Pero that this is a very good package, no? Equationmatic. Okay, balik tayo dito guys. Balik tayo dito. So we created a model, di ba? Mod 1 natin. And then ano ba laman ng mod 1? So ito yung mga laman niya. Okay, coefficients, residuals, effects runs. Actually guys, kung gusto niyo kunin yung mga laman nito, no? You can easily do that. So how do we do that? Example lang. Mag-insert tayo dito ng ano, Control Alt I, okay? Mag-insert tayo ng panibagong chunk. And then mod 1 dollar. Yan, lalabas yung laman ng mod 1, di ba? So if you want the coefficients, okay, lagyan natin coefficients. Run natin. So ito yung coefficients niya. Okay? So you can, if you want to get the other other parameters, other contents of your regression model 1, ito naman yung residuals, no? Pag clinic natin yan guys, ito yung mga errors. Okay? So, di ba ito kino-compare yung ano, yung actual value with the predicted value. So ito yung mga errors natin. So nasa mod 1 din yan. Okay? Ano pa? Mod 1 dollar, tingnan pa natin to, no? Okay, so okay, ito naman yung model natin. Ito spreadsheet, tingnan natin. Mod 1 model, enter natin. Yan. Okay? So ano tong mga to? Ito yung mga actual values natin, no? Log output, log labor. It just gives us the actual values. Okay, and then let's one more, mod 1 dollar. Okay. May effects, may fitted values din, no? Tingnan natin effects. Then run natin. Okay, so ano tong effects na to? Negative 1.2 intercept, then log labor, log capital. Okay, so okay, hindi ko pa na-decipher to. Okay, I'm not sure kung ano yung effects na to. Or this could be the equation mismo, no? Hindi rin eh. Hindi. Okay, suspend muna natin yung discussion ito. First time ko lang na nakita tong effects na to, no? Okay, etc. Guys, it was just meant for us to be able to get what are the elements of your mod 1 object, which was the result of a linear regression model. Okay, so let's go on here. And then ito, yung Stargazer na ano guys, you can generate the result of your mod 1, okay, in a good format. Ito, di ba? Maganda yung format pag Stargazer. So ito yung dependent variable natin, log output. Then you have these variables, log labor, 0.468. Okay, and then I think this is the standard error. And then log capital, 0.521. significant at ilan to? 0.1%, no? Okay, and then the constant. And then sa ilalim yung summary, 51 observations. R squared is 0.964, adjusted R squared is 0.963. Then you have your F statistic, okay, highly significant. Degree of freedom, number 1 is the number of regressors. So dalawa log, capital log output, and degree of freedom 2, that's your N minus K minus 1. So you have 51 observations, minus K, which is 2 regressors, minus 1 to compensate for the intercept. So that's 48 degree of freedom 2. No? Ito yung ibig sabihin ng tatlong stars. No? So pag tatlong stars, significant at 0.01. Okay, so that's from the Stargazer function. And of course, we can get the AIC and BIC. Kunin lang natin to. Okay, 14.85 at saka 22.58. And again, guys, this doesn't mean anything unless we compare it with another model. Okay, so let's now go to, okay, this one will now plot yung sa diagnostics natin. So i-plot natin to partition, number of rows 2 by 2. So i-plot natin yung sa model 1. Okay. So let's just quickly look at this, diba? Diniscuss natin to dati. Yung number 1, it's a plot of your residuals versus your fitted. So mukhang okay naman siya, no? So dapat kasi yung plot natin dapat dito dapat walang pattern or almost a straight line. Then yung normality ng residuals, meron tayong medyo mga high levels, itong 320 at saka 80, medyo malayo sila dun sa sa QQ plot natin. Itong scale location din, it's also a measure of homoscedasticity, no? So medyo may pababa dito, ibig sabihin para may pattern yung variances natin. Okay, also this one, yung Cook's distance, is a measure of influential points. No? Kasi ang influential point is different from an outlier. Pag influential point, okay, ibig sabihin nun, that particular point has the capacity to change the regression output. So itong 32 na to at saka si 190 na to, ibig sabihin dapat yan medyo i-inspect, no, tingnan kung talagang influential point sila. Okay, so ito sabay-sabay na linagay, no? Okay, of course, this is only the visual aspect. Pwede namang, meron naman tayong statistical way to check yung validity ng model natin. Okay, so dito, we can, pareho lang sa taas yan, no? Pareho lang sa taas, yan yung plot natin. Kaso ito, ini-specify lang natin, guys, one at a time. In fact, dito ang nag-a-appear 4 lang, di ba? Dito sa plot ng model 1 natin. But there are actually 5, no? So, tingnan natin. Plot model 1. Ito yung number 1 natin, yung residuals versus fitted. No? Tapos itong number 2. Okay, ito na yung normal QQ plot natin. Okay, number 3. Ito na yung scale location, no? Which is the third one here. Ito. Okay, and then there's number 4. Ito, number 4. Ito na yung wala dito sa taas, no? Ito yun. So it gives us the Cook's distance. Okay, ano ibig sabihin nun? Cook's distance. The higher, guys, the Cook's distance, the more that particular observation could be a candidate for being an influential point. So yung mga influential point, guys, kailangan ng aralin yan, kailangan tingnan kung talagang nakaka-influence sila dun sa regression output. Okay, and then yung last will be residuals versus leverage. Okay, so ito yan. Alright, so 5, yung 4 na to, guys, andi dito yun, except yung number 4, yung Cook's distance. Okay, So what is this telling us, guys? It's not enough just to generate your regression model. Kailangan, guys, titingnan natin diagnostics, titingnan natin yung mga assumptions. Assumptions ng linearity, assumption ng equal constant variance yung residuals, yung homoscedasticity, assumption ng multicollinearity, etc., etc. So we have to look at that. No? We'll have a session na titingnan natin lahat yun. Okay, then we can use this from the GG45 na package. We can auto-plot. For me, I find this to be a better plot compared to just the plot, yung ordinary plot dito sa taas. Okay. So para sa akin, mas maganda yung yung generate na auto-plot ng GG45. Okay, so same thing lang naman. So it's your choice, no, kung ano yung pwede nyong gamitin. Okay, actually we can, guys, compute for the Cook's distance for each observation. Diba ito? So nakita natin this one. Diba yun, no? So this is 32, 19, and 27. So those are your observation number 19, observation number 27, observation number 32. Sila yung medyo matataas yung Cook's distance, no? And there's a certain parameter, we will not look into that now, kung paano dinidetermine kung based on Cook's distance, kung candidate siya for an influential point. Okay, so we have this. Okay, so we can round and sort the Cook's distance of model 1. So it decreasing natin, and then 3 decimal places. So let's just check this. Okay. So ito, guys, number 32, 0.447, number 19, 0.26, number 27, that's 0.167. Yun ang nakita natin kanina dito, di ba? Dito sa number 4. Okay, where observation number 32 is around 0.4 something. No? Tapos observation number 19, somewhere here, 27. Sila yung top notchers, tatlong top notchers in terms of Cook's distance. So nakalagay dito yan. No? Okay, so let's see kung makikita natin kung i-view natin yan. View, see this, Cook's distance. Okay, ito. No? See? 32, 19, 27. So ito yung nila, ito yung mga Cook's distance. And there's a parameter para sabihin kung possible siya na influential points based on the Cook's distance measure. We'll discuss that when we go to diagnostics. Okay, so let's move on. Let's continue. Okay, let me close this. Any questions so far, guys? Any questions so far? Okay. Now, remember we use the OLSRR package for yung stepwise regression, di ba? Yung forward at saka backward. May ibang gamit din yung yung OLSRR, hindi lang yung pang stepwise. Sa OLS, pwede natin gamitin yung function na OLS plot, okay? OLS plot ng Cook's distance, bar, chart. Then we have this DF betas and DF fits. Ito ginagamit dito, guys, to determine influential points, pero we'll discuss that next time na. Ang objective natin ngayon yung structural form. So let's run this. Okay, so we have 4 plots, no? Okay, so actually maganda yung sa OLSRR, di ba? Okay, ito, no? Influential points, ito si 32. Okay. DF fits to, no? Let me go to, okay. All right. So ang threshold ng Cook's distance daw is 0.078. Okay? Para maging normal siya, dapat less than 0.78. Pag naman siya, guys, pag red here, okay, since the Cook's distance are greater than 0.078 yung mga Cook's distance nila, so these are outliers, no? Pero guys, iba yung outliers, ha? So ito sinasabi lang natin na outliers sila, but we will have to test further kung influential points sila. Okay? One way to test it, guys, is remove yung remove yung data na to, yung data number 32, and then run the regression again. And try to see if there's a big change, no? As far as your regression output is concerned. Okay? Kasi yung mga influential points, guys, sabi natin, nakaka-affect talaga yan sa output. Okay. So, this is now for the, ito yung bar chart ng bar plot siya. Ito naman yung chart lang, line lang, pareho lang din. Okay, ito naman yung DF fits. Okay, influential diagnostics for the three variables, no? For the intercept, for the regressors. Okay, so ito, sinasabi sa DF betas, ang threshold nito 0.28, no? So itong tatlong to, lumalampas dun sa 0.28. Okay, ganun din dito guys sa sa DF betas for log labor. Okay, we can see here that 27, 32, ano ba to? 27, 30, anong number to? 32 pala to, no? So medyo consistent guys yung mga points na to in 32, 27, no? Okay, in terms of log cap or log labor. Okay, even in the intercept, no? So they are really candidates for influential points. Okay. All right. Clear yun, guys? Clear? So I would, guys, na i-research nyo rin kung how to interpret the Cook's distance. No? Kasi nakuha na naman natin yung value. Eh. So is that a reason to consider these points, these observations as influential points? Okay, kasi yung model natin, we only have 51 observations. No? So tatlo dun sa observations natin, medyo sabi natin possibly malakas yung influence niya. Okay, now there's another way to test kung outlier lang to, no? Outlier test using the Bonfirini test. No? Okay, so let's do this. This is from the CAR package. Okay, and we linode na natin si CAR package. So anyway, nakalagay dyan or pwede nyo ilagay dyan. This is also good practice unless kabisado nyo na kung saan nanggaling ng output yan. Okay, si outlier test, tingnan natin. Okay, okay, Bonfirini P. Okay, anong sinasabi nito guys? What is the null hypothesis here? Kasi test to eh, di ba? So dapat may null hypothesis, no? So how do you find that out? Okay, of course, pwede nyo i-research. Importante guys in any hypothesis test, kailangan alam nyo yung null hypothesis. Tsaka alam nyo rin yung, of course, pag alam nyo yung null hypothesis, it follows na malalaman nyo rin yung alternative. Because you can only conclude guys kung alam nyo yung null hypothesis. Kunyari, ang null hypothesis ba nun? Banito, there are no outliers. Okay? Kasi kung yun ang null hypothesis, then this means, guys, that we what? We reject the null hypothesis that there are no outliers. Ibig sabihin, there is the presence of outliers. Okay? And yun talaga yung case, guys. No? So dito yung null hypothesis, if you want to write it, there are no outliers dun sa residuals natin. And when we run that, guys, ano nangyari? The p-value using the Bonfirini test is that it's less than 0.05. No? Okay, so do we reject or do we not reject? We reject. No? We reject the null hypothesis that there are no outliers. So ibig sabihin, may outliers nga. Okay, but then again, guys, yung outliers, okay lang yan, no? Ang importante, outliers na influential. Kasi not all outliers are influential. All influential points are outliers, but the reverse is not true. So pwedeng maging outlier yung isang data pero hindi siya influential. Pero lahat ng influential data points guys are outliers. Okay, ito din, no? QQ plot, mod 1, tapos yung pangalan ng natin. All right? So ito talaga si 32, no? Super bukod tangi talagang lumalabas guys si 32. And this is plotting your studentized residuals at saka yung T quantiles natin. Okay, so, and then leverage plots, guys. Okay. Leverage, ano naman to? So meron tayong outliers, meron tayong leverage points, at saka meron tayong influential points. So magkakaiba yung mga yon, no? So I want you to find out ano ba yung mga leverage points na yan. Okay, ang leverage points ba, ano ba yan? Outliers ba rin yan? Okay, anong effect nila sa ano natin, sa model natin? Kung may mga leverage plots tayo na ganito, may leverage points tayo, no? Okay, so I want you to find that out first, but we'll discuss that in greater detail next time, no? Okay, ito naman, guys. So ito, I'm already giving you test on the model, no? Sapiro test natin, this is the test for normality. Di ba sabi natin, as much as possible, dapat yung residuals natin normally distributed. Kasi that's an assumption of your classical linear regression model. So using the stats package, okay, kunin natin sa library, guys. Hindi ako yata nasama doon. And then, we use the Sapiro test. No? Sapiro test. Okay. All right. Sapiro will test, normality test. P-value is 6.93. Okay. Less than 0.05. So, ano yung ano nito? Ano yung null hypothesis nito? Okay. So, I want you to research on that. Ano ba yung null hypothesis ng Sapiro will test? Kasi hindi natin makukonclude to kung hindi natin alam yung null hypothesis. So is this telling us that ang null hypothesis ba nito, the residuals are normally distributed? Kasi kung ganun ang null hypothesis niya, then our conclusion is we reject the null hypothesis that the residuals are normally distributed. It turns out that your residuals are not normally distributed. Kung ganun, ha? So kindly check what's the null hypothesis for the Sapiro-Wilk normality test. Okay, so you notice, guys, that we were moving on from the visuals lang. Kanina tinignan natin, di ba, yung QQ plot. Napansin natin na medyo may ano siya, may tendency to go up, no, towards the tail. Ibig sabihin may mga presence tayo ng mga outliers. Ito ngayon, guys, yung statistical test. Okay. So here now, multicollinearity. Okay, paano to? Multicollinearity. Di ba, sabi natin si log capital at saka si log labor, medyo ano sila, medyo highly correlated, no? So let's see. So from the car library, okay, let's na-load na natin naman to, no? Let's compute for the variance inflation factor. There. Okay. Okay, so ano ibig sabihin ng variance inflation factor? Okay, so I want you to find out ano ba dapat yung ano niyan, ano dapat yung limit. No? So ang generally, guys, kapag more than 10 siya, no? Okay, sige, tingnan natin dito, ha. Okay. For us to, para ma-clarify sa inyo, no? VIF to measure sorry, nakalimutan kong maglagay ng ano ng link. Okay, either we can use pwede itong analytics with Haya, no? Okay, or tingnan natin itong Investopedia. Okay. So what's the VIF, guys? It's a measure of multicollinearity among the regressors. So importante ito kasi sabi natin, di ba, ang isang assumption ng ano ng classical linear regression model, dapat walang multicollinearity, no? The regressors, the independent variables should not be related to each other. Okay. So may standard na ginagamit, guys, when we compute for the VIF, okay, with the Investopedia. Okay, ito. Okay, So dito ang ginagamit niya 5, no? So iba-iba yung factors na ginagamit. Here, VIF of 1 indicates two variables are not correlated. Okay, so ito yung VIF table na to. A VIF between 1 and 5 indicates moderate correlation, and a VIF greater than 5, high correlation, kung may multicollinearity. So ito, weight with blood pressure, body surface area with blood pressure, body surface, ito pareho lang to, no? Etc. So in this case, makikita natin dito guys na yung mga dark green na to, yan, highly correlated siya, no? Tapos itong light green between 5 to 10. Okay, yung iba guys ang ginagamit benchmark 10. So depende sa study, depende sa nature ng study. There are those who are really very strict, kunyari sa medical field, or I've seen in banks na ang ginagamit nilang VIF1. No? Okay, so that's just an example guys of how to understand. Tingnan pa natin dito. Okay, let's see. This is from Analytics with Haya. Okay, clear tayo so far, guys?
Yes, sir.
Okay. So VIF natin dito. Let's see kung ano yung. Okay, so this is how to. Okay. Use of service. Yan. Ito, guys. Ito naman according to Analytics with Haya, no? Sabi niya, ang value nga pala ng VIF, guys, it starts with 1 and it does not go lower than 1 kasi if you take a look at this equation, ito equation niya, no? It's 1 over 1 minus r squared. That's how you compute for your variance inflation factor. Okay, since r squared normally cannot be equal to 0, no? Or pwede maging 0 siya. Ang lowest value niya 0. Okay? So pag naging 0 siya, guys, so 1 minus 1, 1 over 1. So that's 1 na lang yung VIF. Kapag r squared naman is very high, no? Kunyari 0.9, ano nangyayari? Remember r squared, guys, is a measure of yung coefficient of determination, di ba? Or correlation squared, no? Correlation R, yung correlation ng dalawang variables. Pag mataas to, pag mataas yung correlation, kunyari 0.9, ano mangyayari sa VIF natin? 1 minus 0.9 squared, that's 0.81. So 1 minus 0.2, okay, so that means 5. So tumataas guys yung tumataas yung VIF pag mataas yung correlation ng dalawang variables. So if the two variables have a very high correlation, VIF becomes very high. So dito sa standard na to, ano sabi niya dito? Let's see. So I've seen different standards, guys, no? So I normally ang ginagamit ko mga 5 to 10, no? Or 10 above. Ito guys, so if VIF is equal to 1, therefore no correlation between the independent variable and the other variables. VIF exceeding 5 or 10 indicates high multicollinearity between this independent variable and the others. Okay, so if we take a look at this, gender, 2.2. So, mababa lang, no? Pero yung age, guys, age, 13.7 yung VIF niya. Ibig sabihin, highly correlated dun to sa ibang variables. Years of service, ganun din, 10.29. Education level, 2.4. So, may problema tayo dito sa dalawang to. Yung sa age at saka years of service. Okay, let's go back to our model. Ito. So, log labor and log cap, 12 sila, no? In fact, pareho lang sila kasi yun ang VIF. Silang dalawa lang naman yan, eh, no? Okay, that means, guys, we have a problem with multicollinearity. We'll address that in a while. Okay. Last, guys, yung variance natin. Di ba sabi natin dapat yung variance, pag prinat natin yan, dapat ano lang yan, parang random lang, no? Dapat wala siyang trend, kaya walang fanning out. So we can use we can use from the LM test package yung Bruce-Pagan test. Okay? Bruce-Pagan test to test for presence ng heteroskedasticity. Ang null hypothesis nito, residuals are constant, okay, homoskedastic. So we would want our model to, ang gusto natin model natin, ang p-value niya should be greater than 0.05 so that we don't reject the null hypothesis. Okay, so let's run this, yung BP test. Okay, there guys. Okay, so this is the studentized Bruce-Pagan test. Okay, the BP value is 4.864. P-value is 0.08. So conclusion natin, guys, our conclusion is that we fail to reject the null hypothesis. Okay, there's strong statistical reason to believe that our residuals are constant. So homoskedastic yung residuals natin, okay tayo. Okay, ang problema natin dito sa multicollinearity, no? Okay. Okay, then we have this other function, yung GVLMA function. Ito maganda rin to kasi nagpa-perform siya ng global validation. So, ibig sabihin, tinitingnan niya yung skewness, kurtosis, heteroskedasticity. So, i-run natin to. So, let's create this object called GV model. And it's the GVLM of model 1. And then, i-summarize natin. Run natin to. Okay, so you'll have several outputs here. Okay. All right. Rinan niya yung regression, ito, yung pareho sa taas, no, kanina. And then, ito sinasabi niya dito, no? Okay. As far as skewness is concerned, okay, so hindi normally distributed yung ano natin, no? Okay, as far as kurtosis is concerned, hindi rin. Pero ito yung tinitingnan muna natin ngayon, ha, yung heteroskedasticity, yung in terms of yung residuals natin, kung constant ba siya. Okay. Here, using the GVLMA test, constant naman yung ano natin, yung residuals natin. Yung skewness and kurtosis, di ba, measure yan ng measure yan ng normality, kung normally distributed yung data natin. Eh, di ba, ano naman, we were able to find out na hindi nga normally distributed, di ba? Sana yung kanina, yung test natin for normality, ito, di ba? Ano lumabas sa Sapiro test, guys? Are the residuals normally distributed? Okay, p-values less than 0.05. Null hypothesis, the residuals are, or the distribution of the residuals are normally distributed, so we reject. So lumalabas nga dito na hindi normally distributed yung residuals, yung distribution ng residuals, hindi normally distributed. Pati dito sa sa GVLMA test, no? Hindi rin siya normally distributed. Skewness and kurtosis not satisfied. Okay? But we'll worry about yung normality ng residuals. Okay, hindi tayo masyadong hindi tayo masyadong hindi tayo masyadong particular ngayon, no? So, anong tatanggalin natin, guys, no? Anong tatanggalin natin? So, kasi dadalawa lang naman, guys, yung variables natin, di ba? Itong log labor at saka log cap. And since they are highly correlated, we have to remove one of them. Okay, so magtatanggal tayo dito. So since si guys, si log cap, ang mas kaya i-explain si si 0.52 siya. Okay? Tapos si log labor 0.46 lang. So let's try to remove log labor. Ano bang ginawa dito? Okay. Hindi. Ang tinanggal dito, log cap, no? Okay. Okay, so tinanggal dito yung log cap. Although parang kung ako siguro magtatanggal muna since mataas yung mas maano yung effect ni log cap kay output kaysa kay labor, I would have chosen this, but why did I choose first log cap? Okay, sige. Sige, let's do this na lang muna, no? Model 2 natin, log output regress on log labor. Pareho din, guys. We're just calling it model 2. Okay, then let's run this. Okay, ano nangyari? Log Ba't log? Dali. What name did I use? Mali ba yung pangalan ko? Ay. Log output ba yung ginamit ko?
Sir, yung
Log
nilagay
output.
mo, log out.
Oo, sorry. Kulang yung ano ko. Apologies. Okay, log. Asa na? Go down. Here. Okay, kulang ng ano ko. Kulang yung log output. Okay? Log output. Let's run this. Okay, what happened? All right, both are significant, no? Log labor. Okay, and then okay yung F ano natin, F p-value F stat natin. Okay. Can it be changed? Okay. Length of null can it be changed? Okay. All right, ito yung Stargazer natin. Log labor constant. Ano nangyari guys sa adjusted R squared? 0.94, kanina 0.98, di ba? 0.99 ba? So lumiit siya. Expected kasi binawasan natin yung ano eh. Binawasan natin yung ano yung regressors natin. Okay? And then let's see AIC BIC, bumaba ba yung AIC BIC natin? Tumaas, no? Tumaas, naging 3642 kasi kanina yung AIC natin. Okay, let me run that. AIC mode 1 para ma-compare lang natin. AIC BIC mode 1 run 1422 versus 3642, no? Bumaba yung ano natin, tumaas yung AIC natin. Okay, ibig sabihin nun actually mas maganda si model 1 kaso nagva-violate nga ng multicollinearity si model 1, no? So that's why we had to do something about it. Okay, and then how about ANOVA? ANOVA, guys? Okay. Ano conclusion natin dito? Model 1 natin, output, regress on labor. Model 2, output, regress on labor and capital. Ano yung null hypothesis natin dito, guys? You recall, guys, yung null hypothesis natin? When we're comparing to regression models?
Restricted models
Is what?
is better.
Correct, no? So dito, the restricted model is better. Yung restricted natin dito, yung isa lang yung regressor, no? So statistically, guys, sinasabi nito na mas maganda yung ano, yung model 2 where you have log labor and log cap. No? Mas maganda siya. Kasi based on our analysis of variance, we're saying here that ang claim natin kasi mas maganda yung restricted model na isa lang. Kaso we're rejecting that hypothesis kasi yung ano natin yung p-value natin is less than 0.05, no? Okay? So it turns out that in ANOVA, mas maganda si model 2 yung we use both log labor and log cap. Kaso nga lang guys, di ba, ang problema natin diyan, ang problema natin sa model dun sa ano natin sa model natin is that may multicollinearity tayo, no? Okay. So sige, tingnan lang natin guys yung ano yung model 2 natin kung okay, andun na naman si 32, no? Okay, so halos pareho lang din, ganoon din yung ano. And then assuming guys na model 2 yung pipiliin natin, then we go through the process again of going through the diagnostics of model number 2. Okay, so iwan muna natin guys yung discussion ng diagnostics kasi we'll have a special session for that. Next week, may isang session tayo na panay diagnostics lang tayo. Okay, so ito naman guys, okay, so simulan ko lang to. Ano naman tong lean model? Okay, yung lean guys, walang log, no? Walang log, linear. So ito alam na natin to kasi ganito naman yung ginagawa natin dati pa, no? So linear model. So let's create another model, model 3. LM. So ito na, output, labor, capital. Wala tayong problema dito. Okay? Then, what summary to? But OLK? Sorry, summary to ng model 3 dapat. Okay, Stargazer, AIC, run natin to. Okay. All right. So significant si labor, significant si capital, intercept is not significant, it's okay, doesn't matter. So how do we interpret this, guys? How do we interpret this? Ito yung unit na, no? Unit na to kasi lean lang to no? Wala tayong, hindi natin in-interpret yung elasticity. So for every $1 increase in capital, there's a corresponding $9.95 increase in output. Ito naman, for every $1 increase in labor, there's a corresponding $47.99 kasi to the 1 to, no? Increase by 1 decimal place. $47.99 increase in labor, nga pala, ceteris paribus, no? Okay, and then the multiple R squared here is 0.9803. Okay, question. Sino mas maganda, guys? Si model number 1 o si model number 3? Ilan yung adjusted R squared ni model number 1? Ilan? Hello? Fourth, ilan yung ano, yung adjusted R squared ni ni model number 1?
Parang 96 po yata yun. Wait lang.
96%. Paki-check nga, 96%.
Yes, 9.9627.
Okay, 96.27%. Model 1. Model 3, 98.03. So in terms of adjusted R squared, sino mas maganda, guys?
Model 3, sir.
Model 3. Okay, tingnan nga natin yung AIC at saka BIC nila. Okay. In terms of Akaike and Bayesian information criterion, which is better? Anyone? Tawag na lang ako. So, Aubrey, sino kaya? In terms of AIC and BIC, kasi kung i-compare natin dito si AIC Model 1, BIC Model 1. Tingnan natin tong apat na to. Okay, Aubrey, sino mas maganda in terms of AIC?
In terms of AIC, sir, mas better po yung mod 1 since mas lesser.
Correct. Hindi restricted Yung restricted natin si Model 2. We're comparing Model 3 and Model 1. No? In terms of R squared, sino mas maganda? Mas maganda si Model 3, di ba? Tama ba? Model 3 kasi 98% Sabi ni fourth 90, saan yun? Nawala yung output ko, no? 98% daw. Si 96% lang something. Okay, 98%. Okay. So, sino mas magandang model, guys? Model 3 or Model 1? Chadwick, sino mas maganda? Model 3 or Model 1?
I'm not sure, sir. Pero model 1?
Kasi may parameters tayo, no? In terms of R squared, mas maganda si Model 3, di ba? Pao, in terms of akaike, sino mas maganda? Is Pao here? Okay, Matthew, in terms of akaike, sino mas maganda?
Model 1, sir.
Model 1, di ba? Pero in terms of R squared, mas maganda si Model 3. I-try nyo nga, guys. Sige nga, mag-i-ANOVA nyo. Tignan nyo kung ano mangyayari. ANOVA nyo, Model 1 at saka Model 3. Ano lalabas? Okay, any feedback, guys? Ano nangyari sa ANOVA? Nung nag-ANOVA kayo? ANOVA. Mod 3. Mod 1. What happened, guys? Any feedback? Fourth, ano nakukuha mo dyan? Nag-ANOVA ka ng Mod 3 and Mod 1.
Wait lang, sir. Parang nagloloko yung sa akin.
Okay, yung sa iba, guys, sino nakatapos na? Janine, nagawa mo ba? Did you try ANOVA Model 3 versus Model 1?
Yes, sir.
Ano lumalabas?
Sir, yung lumabas po ba, sir, is yung may significance tapos may sum square ng mga labor capital residual.
Okay? Tingnan nyo, guys. No? Nag-ANOVA tayo, no? Okay. So, ano nangyari dito? Actually, guys, hindi pa pwede yan. Okay? So, importante ito, So, is Model 3 and Model 1 better than Model 3? The answer, guys, is no answer. No answer, guys. No answer. Is Model 3 better than Model 1? Answer is no answer ulit. Bakit no answer? Bakit no answer? Why no answer, guys? Because, guys, fourth, what's the dependent variable? What's our response variable for Model 1?
Log output, sir.
What's our response variable for Model 3?
Output.
Okay. What do you notice about them?
Yung isa po naka-log, tapos
Okay, yung
yung
isa.
ascending.
Alright, so no basis of comparison. Kasi magkaiba yung dependent variables natin. So how can we compare, guys? Okay? So please remember that pag nagko-compare tayo ng model, dapat pareho yung kino-compare natin. Diba? Paano mo i-compare kunyari si alpha at saka si beta, magkaiba yan. Diba? So you can only compare a model on log output with another model on log output. Okay? Hindi natin pwede i-compare si log output at saka si output. They're two different animals. Okay? Alright, so the question on whether Model 3 is better than Model 1, ang answer doon, guys, it's a wrong question. We cannot compare them. Kaya ito nga, tinan nyo. Okay? Wala naman talagang result na lumalabas dito. No? Okay? ANOVA ng model number, ng model number 1. Kaya sabi dito, models with response log output removed because response differs from model 1. Okay. So anong ginawa niya? Nag-ANOVA lang siya ng model number 3 to eh. Diba? So nag-ANOVA lang siya. Kung anong una nag-appear dito, model 3, nag-ANOVA siya nun. Okay? Tapos yung model 1 na, in-ignore na niya. Why? because the response differs from model number 1. Okay? So you cannot compare, guys, the model output if the response variables are different. Okay? All right. So, sandali, okay, may binigay ako isang file, guys. Kindly, ito kung pwede, guys, anuhin nyo to, you work on this. Ito naman yung log-lin, no? Log-lin model na to. But let me just flash this. I already also gave this to you. Okay. So, tingnan natin sandali, no? Okay, para may guide tayo. Okay, in-upload ko to, no, dun sa ano natin, sa Canvas. Okay, take a look at this, guys. Okay, structural form. Okay, lin. Ito yung lin, no? Y is equal to beta null plus beta 1x plus your error term. Linear. Walang nakalog. So, ano interpretation nito? Interpretation, given 1 unit change in x, how do we expect y to change? Okay, so ito yung delta y, change in y, is equal to beta 1, change in x. So how do we interpret this? How do we now interpret this, guys? So beta 1 now will become delta y over delta x. Okay, yung delta x natin, ang basa natin, for every 1 unit change in x, if you change x by 1, we'd expect y to change by beta 1. We know this already, guys. No? We know this already. So regular yung pagbasa nito. For every 1 unit change in x, there's a corresponding beta 1 unit change in y. Paano naman kung lin log? Ito. Lin, nakalinear yung dependent variable. Nakalog yung independent variable. Okay? So kunyari, guys, let's assume that x here is let's say 5, no? 5. Kunyari 5 siya. Okay? So, a 1 unit change in x, sorry, not x, B1 pala, sorry. If beta 1 is 5, okay, tapos yung equation natin, yung structural form natin, lin log. Linear yung dependent variable, nakalog yung independent variable. So we read it as if a 1 unit increase in x, okay, sorry, a 1% increase in x. So ang pagbasa natin dun sa independent variable, kasi nakalog siya, ang pagbasa dapat natin yan percent, no? So a 1% change in x will result to a B1 divided by 100 units of y. So i-divide natin yung B1 by 100. Baliktad, guys, kung loglin naman, no? Pag loglin, guys, baliktad, ang nakalog dito yung y natin, no? Okay, so how do we now interpret this? A 1 unit change in x, okay, will result into a 100 times B1. I-multiply natin yung B1 tapos percent. Okay? So kung sino man lagi nakalog, guys, yun ang laging binabasahan natin na percentage siya. Okay? Clear yun? So this is a guide for you, guys. Tapos ito yung log-log, no? Ito yung natin. 1% change in x will result into a beta 1% change in y. Okay, so guided tayo. Ito yung structural form sinasabi ko kasi many students become confused when they interpret, no? Kung paano babasahin niya yung result, kung nakalog yung independent variable, kung nakalog yung dependent variable. So that's how we do this, no? Ilinolog natin yung pina-percent natin yung nakalog. Okay, so be guided by this. Okay, so maybe let's quickly tingnan na lang natin tong loglin, okay, mabilis lang naman to. Then maybe we'll end there, no? Okay, sige, we'll end in let's just quickly import yung RGDP CSV file which I gave you. Okay, import natin. Import ko na rin. Okay, FINTSAR, multiple regression. Oops. Okay, the RGDP. Yan. Okay, RGDP at saka time. No? This is real GDP. Okay, so this is a measure, guys, of real GDP over time across ilang years to? 48 years. Again, guys, sorry for not being able to give you the metadata. 1970 ba tong year 1 na to? Okay, anyway. So ito yung measure ng real growth GDP over time. So habang tumatagal, lumalaki yung yung GDP. Okay. All right. So now here we have a time series. So this is a time series. This is not a cross-sectional data. This is not a panel data. This refers to the real GDP of US yata to, no? In millions, I think, of dollars. Okay, so let's go to our model. Okay, so ilagay ko lang yung when you run, guys, yung import, pwede yung kopyahin dito yung yung Control C, Control V. Okay, so that next time madali ko nang i-ano na lang yan, i-run. Okay, na-view na natin. Okay, tanggalin ko na yung view dito. Okay, structure natin is, okay, meron tayong RGDP numeric and time is integer, no? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. Okay, now since this is a time series, guys, and it was converted as a data frame, we can convert this into a time series. Okay, yung pala 1960 ang simula hanggang 2007. Okay, frequency 1, ibig sabihin yearly. So let's create another object called RGDP1, and TS means time series. Ibig sabihin, kino-convert natin yung RGDP object into a time series. Okay, start at 1960, end at 2007, frequency is equal to 1, and then let's view our RGDP1. Okay, so now ito na yung RGDP1 natin, no? From 1960 to 1965, okay, frequency is equal to 1, although the time appears here as 1, pero it's treated as, tinan nyo, guys, 1960, 1961, etc. I-view nga natin yung RGDP1 natin. RGDP1, open natin. Okay. RGDP1, okay, time. Okay, so, pero ang ano niyan, guys, yung 1 yan, 1960 yan. No? Although hindi naka-reflect dito. Okay, questions so far, guys? Questions so far?
None, sir.
Okay, good. All right. Now, what we're going to do is, kasi di ba malaki yung di ba? RGDP in millions yan eh. So kunin natin log niya. Then gagamitin natin si time na regressor. Okay? So we get the log of RGDP. Okay? Log of RGDP, sorry, yung 1 na. And then head, tinan natin first 6 elements ng RGDP1. Okay? Oops, wait. Ano nangyari? Log RGDP. RGDP1. Mali ito. RGDP1. Okay, I'm calling it log RGDP. And then it's the log of, tama naman. Wait. Let me see my environment. Okay, RGDP1. No? Okay, may question ba? Okay. RGDP1. Where's my RGDP1? Okay, RGDP pa rin siya. No? RGDP1. Okay, and then RGDP log ng operator is invalid for atomic vectors. Pag-iisa lang? Bakit? Huh? Ano nangyari guys sa ano nyo? Were you able to run this? Atomic vectors, hindi naman atomic vectors si ano. Mali yata yung code ko. Guys, feedback please kung ano nangyari sa ano nyo, sa model nyo. Hello? Nag-run ba sa inyo?
Sir, sa akin,
Hindi rin?
hindi rin.
Hindi rin. Okay, so wait, hanapin lang natin. No? Kung mag-add na lang tayo ng ano. Okay, let me experiment on something. No? Okay. Andiyan pa yung sa RGDP natin. Sandali ha. Class RGDP. So si data frame, no? May data frame pa rin tayo. Okay, let me use this, guys. Okay, Control-Shift-I. Okay, so sa RGDP ang gagamitin natin. Okay, let me see what happens. RGDP, okay, I'll call it log RGDP. And then it will be log ng sa RGDP. Okay, RGDP. RGDP. Okay. So what am I doing here? I'm creating a variable log RGDP, and it's the log of from the object RGDP, the column RGDP. Okay, tingnan natin. Okay, so let me now see RGDP. Yan, may log na RGDP dito, no? Okay, nag-log na tayo dito ng RGDP. So I created another variable, log RGDP. Okay. Tapos ito yung time natin, and then may RGDP pa rin tayo dito. Okay, you can see guys that lumiit na yung values ng RGDP natin, no? Nakalog na kasi, nakascale na siya. Okay, so gagamitin natin guys si RGDP, no? And not RGDP1. Okay, iwan ko na muna yan. Okay, so para hindi na tayo magbago ng ano, so that I will not anymore change. Okay, tatawagin ko na si RGDP1 is our RGDP. Okay, guys, I hope you're following. Kasi ang RGDP natin, guys, ito, no? Yan yung bagong RGDP natin, may log na tayo. Okay? Ang RGDP1 natin, yung kanina, yung ginawa nating time series. Okay, si RGDP natin as a data frame. Okay, what I'm going to do is, I'm going to change the name of this, I'm going to, okay, tatawagin kong si RGDP, guys, tatawagin ko to na RGDP1. Since this is called RGDP, I'm going to call it RGDP1 para yung mga andito, yung mga functions, okay, yung mga codes dito, hindi na natin papalitan yung RGDP1. Okay? So that's what I'm doing, guys, no? So I'm sorry, I'm creating this object RGDP1. So sasapawan na niya tong ano masasapawan niya na to. Si RGDP1, ang tawag na natin diyan RGDP. Enter. Okay. Control. So run natin. So tingnan natin guys si RGDP1. Ito na, no? Ito na ngayon si RGDP1. Okay, meron tayong RGDP, merong time, merong log ng RGDP. I did that guys para yung mga plot natin, okay, hindi na babago yung pangalan. So dito ggplot data is equal to RGDP1. Ang x natin yung time, ang y natin yung log ng RGDP. Ito yung time x natin, ito yung y natin. Okay, and then G yung line. Alright, so this is the plot, no? Ito yung plot ng ano natin, ng log ng RGDP. Tapos ito yung time natin from 1 up to ano yun? Okay. Alright, questions so far guys? Pause muna ako kasi baka nalito na kayo eh. Sorry about that. Clear ba? Paki-chat naman please kung clear.
Clear naman, sir.
Okay, thank you. Nakuha niyo yung plot guys?
Yes.
Okay, good. How about the rest? Nakuha ba yung plot? Okay, thank you. Thank you so much. Okay, yan. At least nakahabol kayo, no? Okay. Then, regress natin ngayon. So let's now create a model. Let's call this, tawag na natin itong model. Nag-model 1 na naman, ano? Mapapatungan yung model 1 kanina doon. So why don't we call this model 4? Kaso ang danger nito guys, papalitan natin lahat ng 4 to. Anyway, konti na lang naman. May 4 pa ba dito? Okay. All right. So let's get now the model for model number 4. Okay. Dire-diretso na natin to. Yan. Okay. All right. So we have time as our regressor here. Ba? So significant yung time as a regressor. And then, ang ano natin, ang dependent variable natin is log ng RGDP. Okay. So how do we now interpret this? Paano natin i-interpret tong equation natin? How do we read this? Kapag log lin, guys, paano binabasa? Go back to your notes here. Ito, di ba? Log lin. Okay. Ang nakalog natin si Y. So pag binasa natin si Y, okay, kailangan i-multiply mo siya ng 100. Okay? Para ang pagbasa natin, for every 1 year increase, okay, there is a corresponding, percent to For every 1 year increase, there's a corresponding times 100 mo to. 3.15, tapos lagyan mo ng percent, no? 3.15% increase in, okay, 3.15% increase in output, no? Okay, increase in output ang pagbasa. So ulitin ko, log linear to, no? Pag log linear, babasahin natin guys si time as is for every 1 year increase in time, pero yung dependent variable natin, i-multiply natin ng 100 dyan, tapos percent natin babasahin. Okay? There is a corresponding 3, okay, 1 times 100, 3.15%. Okay, 3.15% increase in output. Ceteris paribus. Wala naman. Okay, isa lang naman siya, no? So hindi na kailangan ceteris paribus. Okay? So ito 'yon, no? Ito yung 0.0314. Okay. All right. So tingnan natin Model 4 na pala to, no? I-plot natin si Model 4, auto-plot. Tingnan natin kung kamusta yung ano natin. Okay. Nako, guys, ano nyo, no? Di ba? Okay. So, mukhang may homoscedasticity tayo, no? Yung residuals, mukhang okay lang naman. Okay. And then, saan na to? Sinasabi niya, generate the regression line. Okay. Nag-generate na natin. Test for normality of residuals. Dito naman ang ginagamit, guys, si Durbin-Watson. So maraming statistical test. Null hypothesis is no correlation among the residuals. Run natin to. Okay, Durbin-Watson test. P-value is 0. So ang conclusion natin, we reject the null hypothesis that there is no correlation among residuals. So mukhang hindi nga normally distributed yung residuals natin kasi may correlation sa kanila. Kitang-kita naman sa plot, guys, ano? Okay, dito at saka dito. Okay. All right, yung other tests, I'll leave that to you first, no? Okay, so let's stop there, guys. That's good. We were able to finish all of this hanggang ano tayo, hanggang nakaano tayo ng log. Yung linear, alam na naman natin yun, at saka log-lin. So next meeting, we're going to finish the rest. Ano tayo examples nito, no? Hindi pa natin na ano yung lin, log. Okay. Log, lin, tapos na tayo. So we have lin, log, and then we have reciprocal models, polynomial. We'll finish this next meeting and then also do more with the diagnostics. Okay? All right, so let me pause first, or let me stop a recording. Okay, stop recording, and then I'll